All right, so we're going to write the recursive formula and explicit formula for each situation. You have a cafeteria card worth $50. You buy lunch on Monday, and its value goes down to $46.75. After you buy lunch on Tuesday, the value goes down to $43.50. So it looks like what's happening is we are adding negative $3.25 each time. So your lunch costs $3.25. So this would be an arithmetic sequence. So if we're going to write the recursive formula, it would be in the form, and I'm going to label R for recursive, it would be in the form of A of 1 is equal to 50, because that's your starting value, semicolon, A of n is equal to A of n minus 1 minus $3.25. If we're writing the explicit formula for this one, it would be A of n is equal to 50 minus 325 times n minus 1. Moving on to the next problem. An accountant starts off with a base salary of $53,000. Their salary increases by $2,000 each year. So what's happening is we're adding $2,000 to our salary every year. So this would also be an arithmetic sequence. So my recursive formula would be A of 1 is equal to, and my starting value is 53,000, semicolon, A of n is equal to A of n minus 1 plus 2,000. My explicit formula would be A of n is equal to 53,000 plus 2,000 times n minus 1. Looking at number 3. Suppose you want to make a reduced copy of a photograph that has an actual length of 8 inches. Each time you press the reduce button on the copy is reduced by 12%, meaning that it decreases by 12%. When we're decreasing by a percentage, remember that's an exponential function. And if we are decreasing by a percentage, our b value, or our rate of change, would be 1 minus that 12% expressed as a decimal, which is going to give you a 0.88. So we cannot forget stuff that we've learned in our last standard. We need to apply what we learned in our last standard to this as well. So this is actually my decay rate that we're going to put into our sequence, and my starting value is 8 inches. So starting with my recursive formula here, this is a geometric sequence because it's more like an exponential function. We would have lowercase a sub 1 is equal to 8 because that's my first term. Semicolon, a sub n is equal to a sub n minus 1 times the number we would be multiplying each term by, which is 0.88. Now my explicit formula is going to be a sub n is equal to, I start with 8, I'm going to multiply each term by 0.88, and since this is exponential, we're raising it to the n minus 1 power. Now number 4, the starting salary at a company is $42,000 per year. The company automatically gives you a raise of 3% per year. So we're growing at a percentage, which means that we need to take our percentage, express it as a decimal, and add 1 to it. So it would be 1 plus 0.03, which is a 1.03. This is your growth rate. And this is acting more like an exponential function because we're multiplying by that 1.03 every time. So my recursive formula, since this is more of a geometric sequence, would be a sub 1 is equal to $42,000 semicolon, a sub n is equal to a sub n minus 1 times that 1.03. My explicit formula would be a sub n is equal to 42,000 times 1.03 to the n minus 1 power. Number 5, a bacteria can multiply at an alarming rate when each bacteria splits into 2 new cells, thus doubling. So we start with a single bacteria. We're splitting into 2, so a single bacteria splits into 2, and then those 2 split into another 2, so that's 4. So we're doubling here. We're not increasing by a percentage, so your rate of change would be 2 because we're doubling, and this is more like an exponential function because we're multiplying by 2 every time. So this is a geometric sequence. So my recursive formula would be a sub 1 is equal to, I start with a single bacteria, semicolon, a sub n is equal to a sub n minus 1 times, since we're doubling, it would be times 2. The explicit formula would be a sub n is equal to 1 times 2 to the n minus 1 power. All right, number 6. Each year, the local country club sponsors a tennis tournament. Play starts with 128 participants. During each round, half the players are eliminated. So we're multiplying by 1/2 every time, which would make this a geometric sequence. So your recursive formula would be a sub 1 is equal to, we start with 128 participants, semicolon, a sub n is equal to a sub n minus 1 times 1/2. Whereas your explicit formula would be a sub n is equal to 128 times 1/2 to the n minus 1 power. And then lastly, number 7, a child puts $1 into a piggy bank. 1 week later, he puts $1.25. The next week, he puts in $1.50. So every week, he's putting in 25 more cents than he did the previous week. So we're adding 25 cents on every week, which means this is an arithmetic sequence. So your recursive formula for this arithmetic sequence would be a of 1 is equal to $1, or just 1. Semicolon, a of n is equal to a of n minus 1 plus 25 cents, or 0.25. Your explicit formula would be a of n is equal to 1 plus 0.25 times n minus 1. And that brings us to the end of this lesson.